All right, let's look at another data structure today called an array list. And I've got a demo program open right now. And what I want to do is just run this thing and walk you through the output. So I'm going to run this, compile it, and run it. And so first off, I guess let's mention what an array list is. An array, right, has this problem where you have to know the size of an array when you create it. And if there's ever any point when you want to add things to an array or remove things from an array, you have to actually create a new array and copy all the elements over. An array list is a data structure that gives us ways to dynamically resize it. So, all right, so the first thing is if you're going to use array lists, we need to have this import statement at the top. This is not something you need to memorize. On the AP exam, you know, you wouldn't be asked to write that line of code. The import is always assumed. I think as we use it, though, you may kind of memorize that one by accident. Now, to create an array list, here is my constructor, and the syntax is a little bit strange compared to what we're used to. Don't worry about why we have the angle brackets right now. We'll talk about that later when we get more into what's going on in the memory when we're working with array lists. But for now, this is just syntax. You can kind of understand what it does rather than memorize exactly how to write it yourself right now. So this is where we're declaring the type of object the type of variable we're going to make. So it's going to be an array list, and in the angle brackets here, this is the kind of data that's going to be stored in the array list. In this case, we're going to store string objects. Okay, so an array list can only store objects. So this is the variable name. That's probably obvious. And then here's the call to the constructor. And the thing that's a little bit different is we're making an array list, but again, we have the kind of data we're going to put into the array list in the angle brackets before the parentheses. And I know that looks a little bit weird. All right. So I made this array list called fruit, and let's check out some functions that it has. So the first one is a .size function. And when we make an array list, it's empty, and the .size returns 0, which makes sense. The size returns 0, and is empty returns true. This will drive you crazy, but you can see it's not a .length with parentheses. It's not a .length without parentheses. It's a .size with parentheses. So, you know, the way I see it, the guys at Oracle, when they were creating Java, the person working on strings, the person working on arrays, and the person working on array lists must not have had cubicles near each other. All right. So, but anyway, just FYI, you know, the compiler will always catch it if you use size for length wrong, and that is not a penalizable or even a testable thing on the AP exam. They won't try to trick you by using the wrong way to access the number of elements in it. All right. So now let's start putting some things in the array. And array lists have an add function, and when you add elements to the array, each just gets, this goes in index 0, this will be index 1, index 2, and so on. And so by the time I finish doing these lines of code, you can see that the size is now 9 and is empty, returns false. And array lists are nice to use because they have they have a nice two-string method. So when you print an array list, you just see the contents. So that's easy. If you want to access an individual element of an array, it's not square brackets like an array, or excuse me, if you want to access individual elements of an array list, it's not square brackets. You have to do the .get, and you pass the index in parentheses. So grape is in 0, 1, 2, 3. All right, so that makes sense. There is an index of function, and this does not exist in arrays, but it does exist in strings and array lists. And this is the object you're looking for. So I am looking for the cucumber string, and I print that out, and it is in index 1. And so here it is, 0, 1. And you can see that there's also a cucumber later in the array. So the index of returns the first occurrence of the element if there are multiple elements in the list. And just like strings, it'll return -1 if it's not there at all. All right. Just to compare the two different ways to add elements to an array, If you just do the straight add function, it appends it to the end of the list. And let me make it so you can see the whole list here. And you can also add by index. And so you do the index, comma, and then the object you want to add. And so the watermelon is at 0, 1, 2, 3, 4. So it will insert at position 4, and then everything, when the insertion happens, everything at position 4 and beyond gets slid over 1, right? So the banana used to be in index 4, now it's at 5, and so on. We can remove elements from an array. So here we are, I'm removing the pair object, and there's two ways to remove. I can say the object I want to remove, and you can see the pair gets, so let's see, where did I? Oh, okay. Here's the place where it happened. Okay, so there's, is there more than one pair on the list? Yes. Okay, so I removed the pair, and just FYI, this function returns true or false depending on the element was actually there. So in this case, it removed true. There's another function, remove, where you can pass an index in, and 0, 1, 2, there is an apple at index 2, and when you remove using index, it returns the object that you removed. So a lot of times we want to use these without even worrying about the return type, but sometimes knowing what was removed, or sometimes knowing whether or not you're able to do it, is also useful information. All right, so I'm printing it out again, and you can see that, when we removed pair, the one between apple and cucumber got removed. So it removes the first occurrence of it. It doesn't remove them all. And you can see that there's still one left. In addition to adding and removing, we can overwrite elements. So if I use the set function for that, and it's 0 and then the object you want to put in, so the apple turned into a jalapeno here. Let's see. Traversing array lists, we can use loops just like we do with other structures like strings and arrays. And so here I'm going to, from 0 to the size of the array. And each time I want to access an element, I just call the get function at its index. When it comes to arrays, I would definitely almost always attempt to use the for each loop rather than a regular for loop, because you can see, this is starting to get kind of messy. It's not as nice with the bracket syntax like you have with arrays. And, so sometimes you end up, if you want to manipulate objects in the array or do something to objects in the array, you end up having a lot of fruit.getI.length or something like that. And the inside of the loop can get kind of messy with lots of dots and parentheses, whereas when you use a for each loop, it can be much simpler. So whenever I'm working with an array list, or an array, I would always think about if a for each loop is appropriate before I try to go by index. All right, generally this will make your life easier. Now, we do have to pay attention. That's like, oh, okay, remember, array list in some cases can be, for looking, but not for changing. So here I made a loop that looped through it again using an enhanced for loop, and I set each string f to guava, and I printed it out again, and you can see that nothing changed. Okay, so I didn't actually change anything using the enhanced for loop, but I did it one more time, and if I wanted to actually change everything, I went ahead and did it, and I'm kind of lost my place here. So here is the one where here is where I can print them all, and it gives me this. Here's printing them all using an enhanced for each loop. I tried to change it, nothing happened. And here I actually changed everything using the set function and printed it out. You can see that everything is actually changed. So, all right. So what do I think you should do? I've got an ArrayList practice function in here, and what I would do is get out a piece of scratch paper, and I would go through this, and I would try to predict the output, and I would write down what you think the output is going to be of this entire program. And after you've predicted the output, then run the program, check your predictions, and figure out what any mistakes are, ask questions if you got anything wrong and can't figure out why. And we should expect a quiz in a couple days where I'm going to give you something basically like this and pencil and paper and ask you to predict the output. All right, I hope that makes sense. Oh yeah, and I guess one more thing is, the syntax for arrays, right? There's a lot of stuff. Like I can never remember whether or not the number goes before the thing being added or after in the set, and what gets returned from the remove function. So I would definitely take advantage of, when I'm working with with arrays, of using this quick reference for the array lists. And I would always have this handy, and it tells you, the order things go and what gets returned. All right. There's just enough where I wouldn't try to memorize any of this. I would always, especially on a test, have that quick reference handy when I'm working. All right. So let me know if you have any questions.